In the last class, we have studied about motion and we have come across different types of motions: linear motion, circular motion, rotatory motion, vibratory motion, and several others. Now, in this lesson, we are interested focusing ourselves what could be the cause of that motion. What causes the motion? So first we will inquire the cause, and thereafter we will study why if you push the car it comes to rest after some time, how you are able to change the shape of an object, and how you are able to change the direction of any vehicle. So all these questions will be answered in this topic. Now let's see what happens to the motion of a car when it is pushed. You have seen that it has gone to certain distance and thereafter it comes to rest. So in the demonstration you have seen that after pushing the car moved certain distance and came to rest. So people thought that the natural state of condition of any object, the natural state of any object is rest. But regarding the motion, Galileo and Newton have studied and made some concrete concepts about this natural state of the object and some other physical quantities. Now, it is very interesting to note that the year in which Galileo died, Newton was born. Now, Galileo has studied lot of types of motions, and then he said that the natural state could be rest or uniform motion. To show this, we have to understand the Galileo's thought experiment. What this thought experiment he has imagined two inclined planes. Now, one inclined plane is placed like this. The second inclined plane is constantly changing its inclination. In the very beginning, this theta 1, next theta 2, next theta 3. This was constantly maintained at theta 1, suppose. Now if you release any ball, the ball will come. If you imagine that it is a frictionless track, the ball will go up to this height. Now, what about the second track? If you release the ball will go up to this same height, but it travels longer distance. Now, what about the third one? The ball will come up to this, but the distance traveled by it is more. What if this inclined plane is exactly making 0 degrees with the horizontal surface? Then it can never reach that height, but to reach that height it should travel continuously. So this thought experiment reveals the fact that to move once the object is under the motion, and if you imagine that it is a frictionless track, then it will be remaining in the same state of condition. So the objects will have, here it is uniform motion. And he has given the natural state of an object is not only rest, but it could be uniform motion. And this property he named it as inertia. Now, what is inertia? Inertia is the property of any object which resists any change in its state of condition. So, it is the property of an object which resists the change in its state of condition. So we can say if the object is already at rest, it remains in rest. If the object is already in motion, then it wants to be in the same state of condition, that is motion. This is the idea of Galileo. Newton has continued the ideas of Galileo and has formulated 3 laws regarding this inertia and the other physical quantity called force. Now let's talk about Newton's laws of motion. Thought experiment. So here I have taken 2 inclined planes. In fact, this is a box and I made this box into 2 inclined planes. Now let me release the marble and see the height up to which it raises. You would have observed that it has risen up to this height. Now we will decrease the angle of the second inclined plane and we will release the marble from the same height. Now it has gone up to this one. Now furtherly we will reduce again, keeping the inclined plane first as it is, but the second one is continuously, the slope is getting reduced. Now it has gone up to this one. So this can conveniently explain the inertia of motion. What happens if this is very flat? and it is opened, then the ball will be continuously moving. In your lower classes, you have studied the definition of force as push or pull. This is pulling. Now I am pushing. The spring is elongated. It is compressed, stretched and compressed. You can see that this car was tied with two different ropes. Now, if I apply force on the left hand side, the car moves towards left. If I apply the right hand side the force, then car moves towards right. Now, if I apply the same force, then the car is unmoved. You can see that I am applying the force through the tension produced in the threads. So here the two forces are equal and they are called balanced forces. So if on any object, if two forces equal and they are acting in opposite directions, the object will be at rest. It cannot move. Then these two forces are called balanced forces. So the conclusion is, if you want to move the object, unbalanced force is required. If I want to move this box, I have to apply certain force. Now I am applying very little force on it. It is unmoved. Why? Because there is an opposing force which is acting between the surface of this box and this lower surface. That force is known as friction. So if I wanted to move this box, I have to apply a little bit more. We will talk about friction just little later. Friction, if you apply the force, if you apply more force, the friction will also be more. But friction will be increasing up to a certain limit. Beyond that it cannot. Now if I apply the more force than that limiting friction force, then I can easily move this box. You can see how much friction is there when I tilt this surface. You can see that the box is still there. Who is balancing this? That friction. Now it starts moving. So if you want to move the object, you have to apply a force that is more than the limiting friction force. Otherwise, the objects cannot move. The same is the reason for why the cycles will come to rest after pedaling once. Similarly, when I push the car, it stops after some time because the friction acting between the wheels and this surface. So that's why it is stopped. There are different types of forces: contact forces and non-contact forces. Now here I have taken one bar magnet and I'll keep another bar magnet here. Now you see, without touching it, I am able to move it. Similarly, without touching, I can attract it. See how it is moving away. So, the force of repulsion or the force of attraction is the example of the non-contact forces. Similarly, the electrostatic forces, the gravitational forces are also the examples for non-contact forces, whereas friction, normal reaction are caused by contact. These are all called contact forces. Now you have seen what is pushing, what is pulling, and what the force can do the other things like stretching a spring and compression of the spring. Now, combining the Galileos thought experiment regarding inertia and the Newton's observation, we can formulate the first law. What is it? What we can write the first law? Every object will remain in same state of condition that is either at rest. If it is at rest, it remains in the rest, or otherwise it is in motion, it will be in the motion, unless and until some unbalanced, we have already studied what is balanced force and what is unbalanced force. We have also discussed the concept of friction in it. Some unbalanced force, this force must be an external force. Unbalanced external force acts on it. This first law, what's the statement? Every object will remain in same state of condition, that is either at rest or in motion, with unless and until some unbalanced force, external force acts on it. So this reveals two concepts. One, it is talking about the inertia. And second, it talks about the force. So first we talk about inertia and then we will talk about the force. Now let's talk about inertia. We have already defined what inertia is. Inertia is the property of an object which resists any change in its state of condition. If it is in rest, it wants to remain in rest, and if it is in motion, it wants to remain in motion. Now, this inertia is measured in terms of mass. More is the mass, more is the inertia. To understand the inertia, let's do some of the activities. This is another simple activity of inertia of rest. You would have noticed that the paper has come out, but the carom coin remain at the same spot. Another simple activity to show the inertia of rest. So you would have noticed when I push with 1, only the bottommost coin is getting displaced, because the force is applied on that particular coin only. Therefore, that coin get the displacement and remaining coins will remain in the same state of condition, that is rest. This is the simple demonstration to explain the inertia of rest. Here I have taken one glass over which I placed one cardboard. Over the cardboard I placed one coin. Now when I plug the cardboard, what happens? Let's see. The coin gets into the glass. So this tells us that the force is applied on the cardboard, therefore it is moved, and as there is no force applied on the coin, it wants to remain in its same state of condition. So that's why it has been placed into the glass. This is a simple activity to show the inertia of rest. I have taken a small toy car and I placed some carom board coins. Now when I give a jerk to the car, then see what happens to the position of the coins. So you would have seen the coins were moved backwards. This is another simple activity to show the inertia of motion. So to do this, I have taken one small toy car and I placed some bunch of coins. Now I'll allow this car and suddenly I stop. Let's watch it. So you would have noticed that the coins were moved in the forward direction. In those activities, you would have seen when a coin is placed on the cardboard and again when it is placed on the top of the glass, when the card is plucked, then the coin gets into the glass. What does it tell us? The force is applied on the cardboard but not on the coin. So coin wants to remain in the same state of condition, that is rest. Therefore, it was simply got into the glass itself. So this is called inertia of rest. And then we have seen the example of the car and the forward jerk of the passengers in a vehicle if driver applies suddenly the brakes. So that tells us about inertia of motion. Now, when the car moves in a straight way and all of a sudden it takes the turn, then the passengers will have the sideways jerks. That is telling us the inertia of direction. Here we have explained the example when the bus or any vehicle starts suddenly, the passengers will experience backward jerk. Why backward jerk? Because the lower part of the body is in contact with the bus and it comes into the motion, but upper part of the body, which was in state of rest, wants to remain in state of rest only. Therefore, it moves backward. So, the passengers will experience backward jerk because of inertia of rest. Now here the passengers will experience forward jerk as the driver applies the brakes suddenly. What happens in this case? The lower part of the body, that is legs, which are in contact with the bus, will come to rest, but upper part of the body, which was in motion, wants to remain in motion. Therefore it moves forward. Here when the bus was going like this, all of a sudden it was turned to left or right. Then what happens? The tendency of the passengers to remain in the same state of condition. As it is turned, therefore they will move away from the center of the circular path in which the vehicle is turned. Now let's define force. It is a physical quantity which brings or tries to bring the change in the speed, shape and direction, or any one of the three. So it is a physical quantity which brings or tries to bring the change in speed, shape, direction. That means if the object is at rest, if you want to give some speed to it, then we have to apply force. Suppose if the object is already in motion and you wanted to stop it, then you require some force. Similarly, if you want to change the shape of an object or configuration of an object, you require some force. Next, if you want to change the direction, then also you require the force. So these three Suppose if the object is at rest, if it is to be moved, I have to apply certain force. Suppose if it is already in the motion and if I want to stop it, I have to apply force. Now if I wanted to change the shape of it, then I have to apply certain force on it. Similarly, if I want to, suppose if something is coming in this direction and all of a sudden it should be turned, then I have to change the direction of it. You can visualize this when you play the cricket. When the bowler bowls the ball, then we have to give some change in direction so that it can go to the boundary. So why I wrote this class which tries to change? Here, as it is a toy car, simply I can make it to move. But if in the case of real bus, can I move like this? It's not possible. So, but still I am applying the force there also. Similarly, once I can easily stop this one, but whereas in if it really a bus comes, I cannot stop it. So my force sometimes may be sufficient and sometimes may not be sufficient. So this is the force. It's a physical quantity which brings the change in speed, shape or direction, or all the three. Because sometimes the force is not sufficient, that's why this clause is also to be added there. So hereafter, whenever you define any physical quantity, immediately you must write the standard international system of units. SI unit of force is Newton. Next, this physical quantity is a vector. I hope that you have remembered the definition of a vector. How the vector which is required both magnitude and direction. So to describe force completely, we require both magnitude and direction. Therefore, it is to be called as vector. What is the other quantity? That is scalar, which can be explained fully with the help of only magnitude. So we have talked about the first law of motion, that is every object will remain in same state of condition unless and until some unbalanced external force acts on it. That gives us the two concepts. One is inertia, the second one is force. We talked about inertia and we have talked about the directions of, the types of inertia, and then now we talked about the definition of force. So this is all about the first law of motion.